Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of 3 is equal to x to the power of 5. So now the first thing I'm going to do is I'm going to subtract x to the power of 3 on both sides. So these two cancel out, and I'm left with x to the power of 5 minus x to the power of 3 is equal to 0. So now I'm going to factor out x to the power of 3. So now I have x to the power of 3 times x squared minus 1 is equal to 0. So now this is going to give me 2 equations. I have x to the power of 3 is equal to 0, and I have x squared minus 1 is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. The cube root of x to the power of 3 is simply x, and the cube root of 0 is 0. So x equals 0 is one solution. Now I have x squared minus 1 equals 0. So now I'm going to add 1 on both sides. So now these two are going to cancel out, and I'll be left with x squared is equal to 1. Now, if I take the square root on both sides, these cancel out, and I'm left with x is equal to positive or negative 1. So these are 2 more solutions to our problem. So now, our three solutions to this problem are 0, 1, and negative 1. So now to check, my original equation was x to the power of 3 is equal to x to the power of 5. So let's first check 0. So if x equals 0, I have 0 to the power of 3 is equal to 0 to the power of 5. Now 0 to the power of 3, this is the same thing as 0, and 0 to the power of 5 is the same thing as 0. So 0 works. Now let's try 1. I have x to the power of 3 is equal to x to the power of 5. Now if x is equal to 1, I have 1 to the power of 3 is equal to 1 to the power of 5. 1 to the power of 3 is 1, and 1 to the power of 5 is 1. So this works as well. Now finally, we have negative 1. So I have negative 1 to the power of 3 is equal to negative 1 to the power of 5. Negative 1 to the power of 3 is negative 1. Negative 1 to the power of 5 is negative 1. So this works as well. So these are my 3 solutions to this problem. Alright, so I have 5 to the power of x is equal to 7. Now I want to find the value of x. So for my solution, first start with 5 to the power of x is equal to 7. Now I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And this property is really important because let's say I have 7 to the power of x is equal to 14. So right now, as you can see, x is really hard to solve for because if x is an exponent, it's going to be really hard to solve for, especially when we know that x is going to be a decimal, because 7 to the power of 1, this is equal to 7, and 7 to the power of 2 is equal to 49. And 14 is somewhere in between 7 and 49, meaning x is somewhere in between 1 and 2. And solving for this in the form that it is really hard. So now if we change it by taking the log on both sides, now I can move x to the front, and now as you can see, x is a real term, and it's much simpler to solve for it. All I have to do is divide both sides by log 7. So now these two are out, and I have x is equal to log 14 over log 7. So it's actually really simple when you use this property. So now this is what I'm doing for 5 to the power of x is equal to 7. So now I had log 5 to the power of x is equal to log 7. Now I can move x to the front. So now I have x times log 5 is equal to log 7. Now I can go ahead and divide both sides by log 5. So now these two are going to cancel out, and I'm left with x is equal to log 7 over log 5. Now log 7, this is equal to 0.8451, and log 5, this is equal to 0.6990. So now I have 0.8451 over 0.6990, which is equal to approximately 1.2090. So this is my answer. All right, so I have 2 to the power of x is equal to 3 to the power of x. So now I want to find the value of x. So for my solution here, first start with 2 to the power of x is equal to 3 to the power of x. Now, I'm going to be taking the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And the reason this property is so important is that, let's say we have the problem 7 to the power of x is equal to 9. Well, right now it's really hard to solve for x because x is an exponent, and we know that x is going to be a decimal because 7 to the power of 1, this is equal to 7, and 7 to the power of 2, this is equal to 49. And 9 is somewhere in between 7 and 49, meaning x is somewhere in between 1 and 2. However, it's really hard to find the value of that by just having x be an exponent. So now if we use this property, and let's say we take the log on both sides, now we can move x to the front, and now as you can see, x is a real term, and now it's much simpler to solve for. All we have to do is divide by log 7 on both sides, and now we have the value of x as log 9 over log 7. So now I'm going to do the same thing with this. I had log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. So now if I move x to the front for both of these, I have x times log base 2 of 2 is equal to x times log base 2 of 3. Now log base 2 of 2, this is the same thing as 1. So now I have x is equal to x times log base 2 of 3. Now if I subtract x times log base 2 of 3 on both sides, I have these two cancel out. So x minus x times log base 2 of 3 is equal to 0. So now if I factor out x from this, I get x times 1 minus log base 2 of 3 is equal to 0. So the only value of x, actually now I'm actually going to go ahead and divide by 1 minus log base 2 of 3 on both sides. And these two cancel out, and left with x is equal to 0 divided by anything is 0. So x is equal to 0. This is my answer. Now to check, I have 2 to the power of x is equal to 3 to the power of x. So I know that x is equal to 0, so I have 2 to the power of 0 is equal to 3 to the power of 0. Now anything to the power of 0 is 1, so I have 1 is equal to 1. And because this is right, our solution is right as well. Alright, so in this video, I'm going to solve the problem 3 to the power of 13 minus 3. So to solve this, I'm going to first start by rewriting this as 3 to the power of 12 plus 1 minus 3. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So I get 3 to the power of 12 times 3 to the power of 1 minus 3. And from here, I can factor out 3. So I get 3 times 3 to the power of 12 minus 1. Now 3 to the power of 12, I'm going to rewrite as 3 to the power of 6 times 2. And that's equal to 3 times 3 to the power of 6 to the power of 2 minus 1 squared. And I'm writing this like this because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into 3 times 729 plus 1 times 729 minus 1. This is equal to 730 times 728. So from here, I'm going to rewrite this as 700 plus 30 times 700 plus 28. So this is equal to 3 times 700 squared plus 700 times 28 plus 30 times 700 plus 28 times 30. Now this is equal to 3 times 490,000 plus 40,600 plus 840, which is equal to 3 times 531,440, which is equal to 1,594,320. So this is my answer.